I'm technically at work, but I am also training. I just signed the offer letter for my new job where they're paying me less money to do the same job as I was doing before. So this is why we're learning Solidity and doing this again. But we're going to be doing this for like half an hour, and then I'm going to try to figure out something to tell my teammates that I'm doing, and then work a little bit, and then come and do another like half an hour session. And then tonight we're going to be doing a lot more of Solidity training. Let's see, we're at 6 hours and 30 minutes, which means why don't we try to get through lesson 5 today? I think that is a very stretch goal. And then half of this lesson was setting up VS Code, so that is not so bad. Now we're going to be getting into the Ethers JS stuff, so yeah.
It to look much nicer. This will make it more readable for you and more readable for anybody else who looks at your code, and it's just really nice. And this line of code for your settings.json is located in the full blockchain solidity course.js, so you can also just copy paste it. We are going to end up overriding that default formatter with another formatter called Prettier pretty soon. But it's great to have a default formatter so that if you don't feel like adding the Prettier code sometime in the future, you can just rely on your default formatter. Awesome. While we're doing formatting, let's also add a default formatter for our JavaScript code. And just to test it out, let's go ahead and create our new file. We'll call it deploy.js.
Okay, so
and in here,
we'll pay the
we can do
ad
something
tax.
like function.
What's up, guys? Alex here from ZBEC. Today I'm excited to see our newest product.
Okay, so if I understood what they're doing correctly, we're just doing deploy.js and not TS, but that's fine. And then we'll just do like export. Is it export default or is it? Is it modules.export? Anyway.
So right now we're connected to a MacBook Pro via the USB
Console.
on the tri-screen. Look at the operating system, Mac, PC, Chromebook, you name it. It also accepts mini HDMI. We've got an adapter as well to allow it to connect to the USB-A port. So now that we've got everything booted up, you can see that we've got all the different screens.
It's like module.
Okay. If you need to drag something from one to another, it's as simple as grabbing that tab, sliding it across, and there you have it.
It's fine. They're just doing
Slide it over.
function.
When you're done, when you tap and go, this is as simple as unplugging each screen, sliding them back into housing. You can shut it down and put the entire product in your backpack. Briefcase, whatever you may be.
Wow, I definitely figured out how to do Node.
This is the ZBEC tri-screen 2. You can learn more at our website at www.dzbex.com. Thanks, guys.
Hi. Console.log. Hi. And then just add, and then just make it look kind of gross. Maybe something like this. If you hit save and it does some auto formatting, that's great. You can actually turn that off by going back to your command palette and saying save without formatting, and that way it'll be saved and not formatted. The way we can add some auto formatting here is we're going to install another extension. This one is going to be called Prettier. So we can just look up Prettier in the extensions here, and you'll want to install this Prettier code formatter. So we're going to go ahead and install this, and great.
I feel like when I do this, it's going to mess up the rest of my machine. Let's see, what do I already have? I think I have ESLint. Yeah, I have Prettier ESLint. If that's close enough.
Now it's installed. Prettier is a code formatter that works for many languages like Python, JavaScript, and even Solidity. And pretty soon, we're going to use Prettier for both JavaScript and Solidity. But for now, we're just going to use Prettier for JavaScript. We can enable this by opening back up our command palette. We'll go to Preferences, Open Settings. And the same way we added a Solidity section, we're going to add a JavaScript section. So we're going to add a comma here.
You should just define this. So in like the package JSON, you import ESLint, and then you should have a ESLint config file, and then have it be defined in your linting file. And that way you don't have to mess around with any of this stuff.
Here. Quotes, brackets, we're going to type in JavaScript, close that, colon brackets, and we're going to do the same thing.
Okay. So, what are we doing? We got the settings JSON here, and we are gonna do I don't know why it automatically did that. Here we go.
Editor.default formatter. And then we're going to do, and then in here we're going to do esvenp.prettier-vs code. And this will make Prettier the default editor for JavaScript. Now, like I said, pretty soon we're going to have Prettier override both of these for Solidity and JavaScript. And we're going to give Prettier some parameters so that no matter who uses your code, they will always have the exact same formatting. But now that we have Prettier in here as the default editor, if we come back to deploy.js and we hit save, it should format to look a little something like this now. We go ahead and we do something like this. We go ahead and do something like this. It'll reformat to look like that. And then additionally, if you want to go back to your command palette, open user settings, not in JSON mode, and we go to default formatter, you can actually even select the default formatter for all languages. If you want to use Prettier for all formatters, feel free to go ahead. All right, great. Got our JavaScript formatter in as well. Let's start writing some JavaScript code. Awesome. So now that we have our code in here, it's time for us to learn how to actually deploy our contract using JavaScript. This is going to teach us a lot about transactions and what's going on under the hood, and even what's going on under the hood in Remix. In Remix, we usually just hit a compile button and then hit a deploy button, and that's really it. In JavaScript, we're actually going to create our own functions that are going to help us do both of those. And as I mentioned, this is the part of the course where we're going to start working with JavaScript and optionally TypeScript if you like. Like I said, all of these sections come with a TypeScript edition as well. So let's set up our deploy.js script to actually deploy our simple storage.sol. So how can we get started here? Well, let's first learn how to run a script using JavaScript and Node.js. So if you want to do a print line or just print something out to your terminal, what you can do is something called a console.log. And if I do console.log hi, I hit save, and I open up my terminal, I can now run node deploy.js, and it'll print out hi. Node is how we say, hey, we want to run this JavaScript code using Node.js. Other languages you might be familiar with, sometimes we'll do Python, deploy.py, or Java C, deploy.java, etc. But with JavaScript, since the front end and back end JavaScript are different, we run code on the back end with Node. And with JavaScript, you can do a lot of things that you'd see in something like Solidity, with a little bit looser of a structure. If I wanted to create some variable, I could say let variable equals 5. This is kind of similar into Solidity, like U256, variable equals 5. But in JavaScript, we use let or var or const. And then I can print this out. I can do console.log variable, and I hit save. JavaScript is optional on whether or not you actually want to have semicolons here. I think Prettier defaults to putting semicolons, and we'll get rid of those in the near future. In your terminal, once you start typing the name of a file, if you hit tab, it could autocomplete the rest of the file name for you. Node, deploy, hit tab, it'll autocomplete. And if we hit enter now, we get hi, and then we get 5, since it prints out hi, and then it prints out 5. JavaScript automatically starts with whatever code you have at the top of the file. So it does console.log first, then variable, and then this one as well. However, a good practice is to actually wrap everything you want to do in a main function and then run that main function. But what we could do is, up at the top here, we could say function main, add some parentheses and some brackets,
No.
closing bracket at the bottom.
That's not a thing. I've never heard of this before. There's a default function, so. But usually it's like something node modules. Node define. No, I just want to read this. What are you doing, Geeks for Geeks? I don't want to get. So, here. Really? Okay. Let's. I'll just do code and then let's see, do I have any? I don't think I have a server here. That's not it. Okay, not that I want to show. Okay, we'll do. Oh yeah, I want to do something like export. This is like modern, and then but like the less modern syntax is because you do like the module exports. So it would be like function whatever, it's fine. The reason why you do this is because if you're outside of this, you'll just be like, you have more control over when it's run, or if it's even run. It's fine. I still think I'm right. Like there's a proper way to do Node. This is not the proper way, and I've never heard of using like a main function. We export defaults, the default one, and then the other ones we can export as well. But yeah.
Save for its auto format. Right now, if we run this, nothing will happen because we've wrapped all of our code in a main function. So if I run it now, node deploy.js, nothing happens because I need something to call the main function. So if I then take this main function down here and I call main, our JavaScript code is actually going to say, the first line of this script is actually this main function here. So now if I do node deploy.js, it'll run high and 5, which is what we want. Now, this is going to be the setup for most of our scripts moving forward, including the scripts that we write when we get to hard hat. However, there is going to be one major difference. Instead of regular functions, we're actually going to use something called async functions, and we're going to do something called asynchronous programming to do this. Now, if what I say next is really confusing for you, don't let it slow you down. Feel free to go ahead and watch that JavaScript course to learn more about this, but I'll also let you know, hey, this is an async function. Here's what we need to be aware of when working with it, okay? But I do want to give you a quick background on asynchronous programming. So far, the programming that we've done has been synchronous. And Solidity is an example of a programming language that's synchronous. Synchronous means it just goes one line after another. If our code looks like this is synchronous, right? Our main function is the first thing that actually gets called. Then we do console.log, let variable equals 5, and then console.log again. This is synchronous programming in JavaScript. All of our Solidity is synchronously programmed. There will be some exceptions to this when working with oracles, but for now, everything is synchronous. JavaScript can be asynchronous, meaning that we can actually have code running at the same time. A good example I like to use to understand the difference is with cooking. In synchronous programming, for cooking, you might put popcorn in microwave, wait for popcorn to finish, and then maybe you'll pour drinks for everyone. Now, this is synchronous programming. Now, it might be a little bit weird for you just to put the popcorn in the microwave and then just stare at it, waiting for it to finish, and then pour the drinks. You typically can pour the drinks while your popcorn is in the microwave. And this is where asynchronous programming comes in. If setting up for this movie night were asynchronous, what you would do is you'd put popcorn in the microwave, and while the popcorn is in the microwave, or drinks for everyone, and then you'd wait for popcorn to finish, since there's nothing left for you to do. But it doesn't make sense for you to wait for the popcorn to finish to pour your drinks. You could just go ahead and pour the drinks right away and then wait for the popcorn to finish. So asynchronous programming is a way for us to do stuff without waiting around for things to finish. And this is really advantageous. And JavaScript by default allows us to do this asynchronous programming. However, sometimes we do want to wait for our popcorn to finish. For example, if instead of just pouring drinks, maybe the next thing instead of pouring drinks was place salt on popcorn. Of course, if we want to place salt on our popcorn, we do have to wait for the popcorn to get out of the microwave. So even though placing popcorn in the microwave has this wait time, we need to be able to tell our code, I want you to actually wait for it, or no, you're good, you can go on and do another task. So that's kind of the difference here. And I'll leave some links in the GitHub repo associated with this course to understand this a little bit better. Functions that come with this waiting period return something called a promise. If put popcorn in the microwave was a function in JavaScript, it would be a promise.
Promises, baby, I'm worth it. Can't read my poker face. She's got to love nobody. Okay. Nobody else does that every time they hear the word promise. It's fine. We're good.
Based function. A promise can be either pending, fulfilled, or rejected. And this is how we know if our popcorn is done.
I did not start recording myself. Okay, so far we have done a little overview of JavaScript. This is going very smoothly because I know JavaScript, which is great. I still think we're going to be doing like a module.exports thing soon, but for some reason this morning it is not working out for me, so sure.
If our popcorn was a method, putting popcorn in the microwave were a function in JavaScript, when we're waiting for the popcorn to finish, it's in a pending state. When the popcorn is finished, it would be fulfilled. And if we aborted halfway through and we stopped waiting, it would be rejected. So putting the popcorn in the microwave returns a promise. With this promise, we have to tell our code, hey, we want you to wait for the popcorn to finish, or you can go ahead and you can just keep doing stuff. So let's put this all together with some JavaScript syntax here. Let's say, again, we're gonna be setting up this movie night, and we need to cook popcorn, pour drinks for everybody, and then we need to start a movie. So let's write some pseudocode to pretend what this code would look like if this was actually a function. So we create some function called setup movie night. And in here, we would say, okay, what's the first thing we need to do? Okay, we need to cook popcorn. So let's say we have some cook popcorn function. So we'll say, okay, cook popcorn. Then the next thing we're gonna have to do is we're gonna have to pour drinks. Pour drinks. So we'll call some pour drinks function. Now, here's the thing. We only wanna start the movie once our popcorn has been cooked and once our drinks have been poured. So if either one of these returns a promise, like cook popcorn, for example, we would need to tell our code here to actually wait for the popcorn to finish. Because cook popcorn is going to be a function where we could say let status equals cook popcorn. And while the popcorn is being cooked, the status is going to be pending. Once the popcorn gets cooked, it'll be fulfilled. If the popcorn breaks, the microwave explodes, the status would be rejected. But we don't want the status to be in a pending situation before we move on. We only want to start our movie once these two functions have completed. And let's say both of these return these promises things. So we need to tell our code, hey, you have to wait for cook popcorn and for pour drinks to finish. So what we can do, now without getting too deep into the weeds on how all of this works, one of the easiest things that we can do, and you'll see us use this syntax quite often, is we'll turn this function into an async function. When our functions are async, we get access to a keyword called await. The await keyword tells any promise-based function to wait for that promise to be fulfilled or rejected. So we say, okay, we want to await for our popcorn to cook, and then we want to await to pour our drinks, and then we can just go ahead and start the movie. And we only start the movie here once these two have been completed. And this is why throughout all of our code, you'll see this await keyword used a lot, but it can only be used in async functions. So basically, whenever you see this await keyword, just know, okay, the function that's being called is promise-based, and we don't want to move on to the next step until that function has completed. So that's a little bit more about promises and asynchronous programming. Hopefully that's clear. If not, like I said, there's some links in the description to learn more about asynchronous programming. The reason I wanted to go through this is because most of the functions that we're going to be working with are going to be asynchronous. For example, when we deploy a contract, what do we have to do? Well, we have to wait for it to be deployed. If we don't use synchronous programming and we just leave our function main like this, what would happen is we would write some code like contract.deploy, and we wouldn't wait for it to finish. Obviously, if we don't wait for it to finish and we try to run some code on a contract that hasn't finished deploying yet, it's not going to work. So we want to do this. We want to have our main function be an async function so that we can wait for our contracts to deploy. We can wait for things to happen. We can wait for our popcorn to finish. We can have the flexibility to tell our code to either wait for our popcorn to finish or continue on. So now that we have our main function as an async function, we're going to add some code to our main function down here. And the code that's added here is some syntax. We're working with asynchronous functions. And if this part is confusing, I'm just going to say for now, absolutely don't worry about this. If you want to try to understand it later, that's fine. But for those who are following along, we're just going to add a at then catch.
So this is also like a asynchronous thing that you can do, and I used to really prefer like the then chaining. In some things, for some reason, like using then chaining instead of asynchronous. Is a common symbol for error. It's kind of like using I for index. So this is saying like then we process the exit, and then if not, we will catch the error. It's a try catch.
Error.
I will take a moment. Sorry for rubbing my eyes. I should probably apologize to my eyes for rubbing them. Yeah, but my eyes are stinging. I wonder, okay, this might not be the right. So console log is very common. But one of the more the console table is also very cool. And the other thing that I got out of this is if you console log with the curly braces, it'll actually output with the object, which is convenient. You don't have to do a bunch of like this. You can just be like that, and it'll log. Curse is 9, so there's that. Why did I stop this to do that? Anyway, I just want you to know that there's like console error, console. There's a bunch of, everyone just uses console log. It's like one thing I actually remember to do, but there are a bunch of different console commands that or functions that you can use. So just wanted you to know about that.
You can follow along typing this yourself, or you can just copy paste it into your code. Basically, what this allows us to do is we have our main function. That's an asynchronous function. So when we call the main function, this is some other syntax for waiting for it to basically finish and then printing any errors it gets. And that's why we do this. But again, if this big lump of code, if you're like, what is going on with this big lump of code? Honestly, for now, just copy paste it. So great. We have our asynchronous function main, we have some code, and then we have this lump of code, which basically just calls our main asynchronous function. Okay, great. I'm going to delete all this for now, but you can still find that comment in the GitHub repo associated with this course. Awesome. Okay, so now that we have our real basic setup, let's go ahead and start coding.
Okay, we're going to stop for now because I probably need to work today. So, or at least I have some things I would like to accomplish at work today. But after my stand-up, I will try to find another half an hour to do this during the day, and then we will spend a few hours tonight trying to push through lesson 5 and get to lesson 6 tonight. Because it would be really cool if we could get like through a lesson a day. That would be 18 days worth. And I think that might be the best way to do this instead of being like, I'm going to complete 4 hours of lesson a day, which we've proven that even getting through 1 hour can be way more than 1 hour. So, yeah, we'll see if we can do this. My original goal was to like, within the next 100 days complete this, but anyway, I will see you next time. Bye.